We're going to use the factor by grouping method to factor polynomials. Factor by grouping. Now, in some cases, you can factor polynomials containing 4 or more terms by removing the GCF from the group of terms. This process is called factor by grouping. So let's do an example. So here I have 4 terms, PQ plus 5Q plus 2P plus 10. Now normally when you see 4 terms, that's usually an indication there that you can probably use factor by grouping method to factor out the GCF. So what you do is you want to look at all 4 terms and then group them into groups of 2. Most commonly you can leave them the way they are positioned and just simply take the first 2 and group them, and then take the second 2 and group them. However, there are some problems where you may have to rearrange the terms before grouping them. The groups will always be in groups of 2, so keep that in mind when you are using the factor by grouping method. So step 1, I want to go ahead and make groups of 2. So the first group would be the first 2 terms. I want to look at them and see what is it that they both share in common. Well, I can see that with the term PQ and the term 5Q that they both share a Q in common. So Q would be my GCF. And then once I take that GCF out, what is left there is the P plus 5. And recall, when you write it, it's GCF on the outside, and whatever is left goes in parentheses. Next, you want to focus your attention on the second group and look at that group and say, what is it that those 2 share in common? Well, I know that 2 times 1 is 2, 2 times 5 is 10, so both terms share a 2 in common. Now they both do not share a P, so P cannot be a part of that GCF. So I'm going to write the 2 GCF outside, and that's a positive 2. And once we take that 2 out, what are we left with? Well, here's a hint. It should be the same remaining term as the first group had. So let's take a look. When we take a 2 out, yes, we're left with a P. When we take a 2 out of the 10, yes, we're left with the 5. So we are left with P plus 5. Now that's a hint. It should always be that way with those 2 groups. So what you did was you're taking out here the process of taking out the GCF. And so this goes back to the little game we played of I Spy. The reason you're not done right now is because I spy a GCF of those 2 terms. And what is the GCF? If you said P plus 5, that is correct because they both share that P plus 5. And then what is left once you take that P plus 5 out is Q plus 2. And there you have it. That is how you factor a group of polynomials to factor the GCF out. That is the process. Let's do another example and look at another scenario. So we have our 4 terms and we want to group them in groups of 2 so that we can take the GCF out. So looking at that first group, we say to yourself, what is it that those 2 terms share in common? And I can see here that the only thing that they have in common is y. So that's going to be my GCF. It goes on the outside, and what's left goes in parentheses. Next, we want to look at our second group of terms to see what is it that they share in common. And you may say, hey, well, they don't share anything in common. Well, all numbers share a 1 in common. It's just implied that. So when you don't see something that they share in common, you can write a 1 out. Now, you can only use that policy for one group. If you look at both groups and neither group has anything in common other than 1, then there's not a GCF. You could only use it once. There's not a GCF, and you would have to do a rearrangement, which we'll talk about later. But back to this problem. So we're going to take a 1 out because all numbers share 1 in common. And what's left goes in parentheses. You're going to write the exact same thing because you know that 1 times any number is that same number. 1 times anything. So 1 times 2x plus 3 is 2x plus 3. Now we're not done with this problem because I spy a GCF. And what is the GCF? Yes, that's correct. It is 2x plus 3. And what is left once you take that GCF out? Yes, y plus 1. And there you have it. Now you're done. And how do you know you're done? Notice that these two terms, they share nothing in common. And now we are finally finished solving or factoring this particular polynomial. 2 more just to make sure you got the concept. So we're going to go ahead and group these in 2 and 2. So looking at the first group, what is it that they share in common? I'll give you a minute to look at it and think about it. So what you should have is 2a. And once you take that 2a out, what is left goes in parentheses. Let's go to the second group. Take a look at it for a moment and see if you can determine what is it that those two numbers share in common. So both groups have a 3 and a b, and what's left goes in parentheses, which you'll notice is the same as what the other group was left. We are not done because I spy a GCF. And what is that GCF? Yes, a minus 2. And what will be left once you take that GCF out? Yes, 2a plus 3b. So there you have it. Let's go to the next example. Again, we want to group them in groups of 2. So looking at the first group, I'll give you a moment to tell me what is it that those two terms share in common. So what you should notice, they do not have a number, a numerical factor in common, but they do have a variable in common. And at most, we always look at the smallest variable, so that most they have 2 x's in common. So x squared is the GCF, and recall what's left goes in parentheses. Now looking at that last group, we want to know what is it that these two terms share in common. And don't forget that little lesson I taught you that remember with polynomials, if the leading term is a negative, you must factor out a negative. And since that second group there, that binomial, starts with a negative, we're going to factor out a -5 that they have in common. And what's left goes in parentheses. Make sure you change the signs of those in the parentheses. And you notice it will be now exactly what was left of the first term. We're not done yet because I spy a GCF. And what is that GCF? You got it. It is x plus 3. And what is left once you take that GCF out? Yes, x squared minus 5. And there you have it. Factoring using the factor by grouping method. Okay, let's factor this polynomial using the factor by grouping method. So if we were to group them into and 2, and you look at the first group and say, I don't see anything they have in common other than 1. You look at the second group, they don't have anything in common either other than 1. You cannot use the 1 for both groups. When that is the case, you must rearrange the terms. In other words, play little musical chairs there, move the terms around and pair them with someone that they do have something in common with. In rearranging them, it doesn't matter the order as long as you pair them with a term that they have something in common with. So to rearrange it, you can rearrange it either way. You can pair the x squared terms with the x squared terms and the y squared with the y squareds. Or you can pair them with the a's together and then pair it with the negative 5's together. It does not matter, but you must rearrange them again so that they have something in common with the term they're paired with. So I want you to pause the video, see if you can go ahead and finish the factoring process. Recall you look at the first group, take the GCF out, then write what's left in parentheses. Do the same thing for the second group. Then you're going to spy a GCF among them, take it out, and then finally what's left would be your answer. Okay, so if you did it correct, it didn't matter which arrangement you chose, you still would have came up with the same exact answer, and that is a minus 5 times x squared plus y squared. Does it matter who's first? No, it does not matter. You can also write it as x squared plus y squared times a minus 5 being in the back. Doesn't matter who's in front as long as you have two groups of binomials and you have the correct terms inside the binomials. Let's do one more example on rearranging the terms before factoring just to make sure that you have this skill down pat. So in this example, I want you to factor by grouping. So if you look at the first group, you'll see that they don't have anything in common, and that is the same for the second group as well, which means that you need to rearrange the terms in such a way to where the terms have something in common with the term that they are paired with. It doesn't matter how you, what I was saying when I got cut off, it doesn't matter how you pair it, you should still come up with the same answer as you can see here. And that's a plus b times x plus y. You could also write it as x plus y times a plus b. And there you have it, rearranging terms before factoring using the factor by grouping method.